Well, in 7.1, using the sine law, we found that we could use that whenever we're given a side and the angle opposite it. Sometimes we're not given that information. And that leads us to a second law, which is called the cosine law. And you can see it looks a little bit more complicated, but really it's the same type of tool where we can carefully identify what we have or what we're missing, and then use this relationship to solve different problems. So here's an example of one that we could use this on. We have a lighthouse and then two ships. One's a ship, one's a freighter that hauls stuff. And we see the angle that we know is from the lighthouse to both of those, but we don't know the side opposite it. What we do know is the sides that surround the angle. And what the cosine law tells us is that if we're looking for a missing side when we know the two sides are on an angle, that this is true, that a squared is equal to 8.3 squared plus 12.5 squared minus 2 times those two values again, and then multiply that by the cosine of the angle, and that's why it's called the cosine law. So typing this in is a little bit trickier than it was on the first section with the sine law, and that's why I'll tell you, if you can use the sine law, use the sine law, because typing it in on your calculator leads to less mistakes. With the cosine law, it's not super hard, it just takes a little bit more repetition. And through my extensive years of doing math, I have found that most people make less mistakes when they start on the far left and work their way, far right, sorry, and work their way to the left. So I'm going to start with the cosine of 68, and you can do this on your calculator as I do it. I would go cos 68, press equals, times 12.5 times 8.3, and then times that by negative 2. And you'll get a number that is negative 77.73. So that tells us what this equals right here, is negative 77.73. And keep that number in your calculator, do not clear it off. Then we're going to add to that 12.5 squared, and then we're going to add to that 8.3 squared. And now we have 147. So now we've got all of this is equal to 147.40, and that continues as well. Keep that number on your calculator. That's what a squared equals. To find what a is, we need to square root this number on our calculator now. And when you square root it, you'll find that a is 12.14, and this is measured in kilometers. So that would be the answer for the distance there. Please do not show your work the way I've done it here with circling and numbers. Just want to show you that so that you could understand where the numbers come from. Ideally, you'll go from the original question to the answer in one step. Another skill that you're going to have to develop here is drawing a situation out here. So you can see here we have a big paragraph of information. How are we going to draw that out? And so just wanted to show you here that you've got to draw things out carefully. And even as I read through it myself here, it's about tiling. And there's a last piece that's going to be triangular. And it's got to be 19 by 20 by 18. So 19 by 20 by 18. So not worrying about drawing it really exactly. Well, this appears to be the longest side, so I'll make this one 20. This one probably the next longest. And then this one. Again, I'm not drawing it to any scale. I'm just drawing it out. Now the question that we're supposed to answer is what is the measure of these angles. So I'm going to label them with letters so that I can talk about them better. And then that also tells me my opposite sides are the opposite, the same letter, but just in lowercase. So this time I am missing an angle, and I'm going to find angle C first. Now you can rearrange the cosine law to isolate the angle. And so you might want to write this down on a piece of paper somewhere, that if I want to find the cosine of angle C, the cosine law says then that I would take C squared, subtract A squared, subtract B squared, and then divide that by negative 2 times A times B. Okay? So that's a different arrangement of the cosine law, and it may be in your book, it may not, so you might want to write that down. In the context of this question, if I start putting in values, we have A and B, which is there, and also there and there. And then we have C, which I'll go in blue. And we're missing angle C, which I already said is yellow. So I'm not going to write the numbers in here because we have the color coding. C is 18. So on this one, in my order, again, is going to be a little bit different. I'm going to start with the blue, the 18 squared. So go 18 squared, subtract A squared, which is 19, and subtract 20 squared. And I will get a number that is, and again, you don't need to show this on your page. I'm just showing this so you can check your work as you go. That's negative 437. Now here's the next step where most people make their mistake. You got to think of this as being in brackets. So when I've now pressed divided by, I'm going to press divided by, and then I'm going to use my left bracket on my calculator, and then I will go minus 2 times 19 times 20, and my other right bracket, and now I'll press equals, and I find that the whole thing equals negative or 0.575. And whenever we're looking for an angle, what that means is, again, on our calculator, it knows that in a right triangle, if the adjacent side over the hypotenuse, which is cosine, is 0.575, what's the measure of that angle? To access that, you press second function or shift, depending on your calculator, and you will find that the angle in this case, angle C, is 54.9 degrees. So now I know this angle is 54.9 degrees. How will I find the other two? Well, if I knew two angles, it would be easy because we know they have to add to 180. But now, how am I going to find one of the other angles? Well, I'm going to find angle A, and I'm now going to use the sine law from 7.1 to find A. So to set that up, I would say I'm looking for A, so sine of A over its opposite side equals the angle that I know, 54.9, over its opposite side, which is 18, and then that brings you back to what we did last time. You could figure that out, and once you know two angles in a triangle, you can find the third just by subtracting it from 180. Okay, another problem here. We have a bush, it looks like, and it says that it's growing on the boundary and it's obstructing the line of sight. The question is, what measurements would the surveyor need to calculate the distance between B and C? So if I wanted to find this distance here, and I will call it little a, what do I need? According to the cosine law, I would need angle A, and then I would need side B, and then side C. That's the information that I would need. It says here that the surveyor measures from A to C to be 322.5. And from A to B, oh, I put it in the wrong spot. That should have been over here. And then from A to B is 247.4. And angle A is 79 degrees. Does he have enough information? Yes. Yes, he does. And so we could then calculate the distance using the cosine law. And again, just to show you how you would set it up, it's the side that you're looking for equals the other two sides squared and added together. And with practice, again, you're going to find this to be easy if you get enough repetition. It's just a matter of plugging it into a formula and then practicing with your calculator. Can you type it in correctly? And then times the cosine of the angle, which is 79 degrees. And again, when we type it in, I would start on the far right and work your way left carefully. So I'm going to leave the rest here. There's lots of problems that you can do, and when you run into a problem, just ask me. I'll be glad to help you. If you can't draw the diagram, if you're not sure why you're not getting the right answer, a lot of it is just the setup and then the calculator part, which you're going to need help with, which is fine. Same deal. You need to get everything done. This is the last part of Chapter 7, so when you're done, you can get the test done. Just make sure that you are, again, doing things on time so that you can find a lot of success and do your best. And again, let me know how I can help you, and I will be glad to do that.